Really early in the quarter, we talked about scatter plots. We talked about what they are, why we use them, and we also learned how to create them on Google Sheets and Excel. Let's recall that a scatter plot is a graph that shows the relationship between two variables measured on the same individual. Now, if you're looking at a point on the scatter plot, that point is going to give you the value for the explanatory variable and the response variable for one individual. In other words, each individual is represented on the graph by a point on the scatter plot. As I mentioned before, the explanatory variable is going to be plotted on the x-axis, also known as the horizontal axis, and the response variable is going to be plotted on the vertical axis, also known as the y-axis. At some point in this lesson, I'm going to make sure to remind you how you create scatter plots on Google Sheets, and so that is coming up. For now, just remember, we use scatter plots to analyze the relationship between two variables. We use the x-axis for the explanatory variable. We use the y-axis for the response variable. Now we can transition into talking about regression lines. I'm going to quickly introduce you to what regression lines are, and I will also give you an intuition on how technology is going to find the regression of the line. We're going to be doing this by looking at an exercise. We're going to consider the table here below. The table shows the number of women in the U.S. House of Representatives from 1980 to 2008. The X value is going to be the year since 1900. For example, if you're looking at the year X equal to 80, this corresponds to the year 1980. We can also take X equal to 100 as another example. If X is equal to 100, this value corresponds to the year 2000. That is 1900 plus 100, that gives us 2000. So very important for us to understand what the X value represents. Again, the X value represents the years since 1900. Now here, the Y is the number of women in the House of Representatives. And notice here, I'm giving you the scatter plot for this data set. On the horizontal axis, we have the explanatory variable, which is the year after 1900. On the vertical axis, we have the number of women in the House of Representatives. Here, we would want to take this table and create a scatter plot to see the relationship between the variables. And notice, we are seeing a linear pattern here. And so now let's talk about what a regression line is. A regression line is the line that best fits the data. Now, try this on your own. Try to draw a line through the data set such that you minimize the distance from all the points on the scatter plot. I'm going to try this from my end. We're not going to get the same line. Again, we're trying to get as close as we can to all the data values or all the data points on the scatter plot. Perhaps it would be better if we try this with a ruler. I'm just going to keep the line that I have on the screen. This is just for us to visualize what technology is doing. Okay? So again, something to highlight here is that the regression line is going to be the best fit for the data. The best fit for the data is going to be the line that is going to minimize the distance from the line to all the data points. Now, we have something called the residuals. The residual is a distance from a point to the line. For each of the points that we have on the scatter plot, we can go ahead and label the residuals. And so it might be hard to do this for every point, but let me just go ahead and do it for the point here at X equal to 80. The residual for this point is going to be the distance from the point to the line. We can also do this for the point at X equal to 88. Again, the residual for this point is going to be the distance from the point to the line. And you can continue to do this for every point. Now, some of those residuals are going to be 0. Look at the last 2 points that I have here on the graph. The line is sitting right on top of those points. So in this case, the residuals are going to be 0. The distance from the point to the line is 0. It's a little hard to see this on the screen, okay? But there's a distance from each of the points to the line. And it could be the case that this distance is 0. We're going to use technology to find the line. This line is called the regression line. This line is going to be the line that makes the square residuals as small as possible. And I should add more details here. I should say the line that makes the sum of the square residuals as small as possible. Your calculator, Google Sheets, and Excel is going to find the line such that the sum of all those square residuals is as small as possible. You can also think of trying to minimize the distance from the line to all the data points. That is what we're saying here. So again, that gives you a good intuition of what is happening on your calculator, on Google Sheets, and on Excel. We're trying to find the line that gets as close as possible to all the points on the scatter plot. That line is what we call the regression line.